more than 45 markets. And we are basically analyzing a lot of images. We arrived to analyze until now 6 billion. I think that it increased. 6 billion product has been recognized for Trax. And recently, in this year, in April, Trax just got a fundraising of 640 million. That has the main
SWB audio capture not registered.
SoftBank, that is a Japanese robotic company. If you don't know about it. So the idea is that if we imagine a product and the lifespan of a product, we have that from distribution, the product is going out from an industry and is moving to the store, and all this part is well tracked by the route market channels. And on the other side, after the checkout, during the checkout, there is all the operation that allow us to track and get insight about the sales and the volume of data. But there is a gap, and here where Trax is trying to fill the gap is in the meanwhile. So what is happening in the shelves? And this is what is very important for brand retailers, because it's where the actual consumer are taking their decisions. So knowing that their product are into the shelf and in which position and the shelf is well furnished is very important from a point of view, economical point of view, for a business and outcome point of view. So what Trax is doing more in detail is basically putting some kind of system that allow to acquire data, and this system can be several, from phones, smartphones, so based on mobile apps, to fixed camera on the shelf that do not allow high resolution images, but still allow enough quality to recognize product and identify product in the shelves, or even robot. We have robot right now in Carrefour and Auchan, and other places also, Auchan, Portugal. And,
SWB audio capture not registered.
In some US market. Then we have other way of acquiring data that can be dome cameras, as well as we talk about drone. We never applied it yet, but can be an option, maybe for big stores like, I don't know, Metro or something like this, big retailer. And the idea is that wait, he's not moving. Yes, oh, sorry. The idea is that all these images are collected and processed in real time, both on embedding system or in the cloud. And with this, the processing is allowing us to basically deliver some insights to the client. And these insights can be the product presence in the shelf, the out of stock, so the product is not in the shelf, the share of shelves, so it's telling us how many facing there are in the shelf. And these are all analyses that can be interesting both for brands, as I told before, or retailers. Some insights are more interesting for retailers, like out of stock, in order to keep always the store furnished and maximize the outcome. And on the other side, the product presence can be very interesting for a brand called, in jargon, is like CPG. All these insights can basically trigger action in the store, immediate action in the store, and give a lot of several reports, and allowing to improve the quality on the shelf and in the stores. To have a general overview of how everything is working, I'm not very fan
SWB audio capture not registered.
Very cool. So I found out a video of Trax, and I would like to share, and starting it.
At Trax, we have a single purpose: to digitize every product in every aisle to unlock the potential of every shelf. We'll take you under the hood to learn more about our breakthrough computer vision platform, where we've developed the world's largest retail image repository that fuels our engines, and our patented deep learning algorithms for retail. We begin by ensuring the completeness of the captured self-images, utilizing an unsupervised learning engine that actively monitors for any data anomalies. We apply advanced image processing techniques to fine-tune every image taken. A unique panoramic stitching engine pieces together the in-store images into a single reference frame to digitally represent the actual full store shelf. And with our fine-grained recognition and geometry engines, we identify every single SKU on the shelf and transform them into granular shelf insights. What's more, our active learning engines automatically recognize new products and displays as they appear on shelves, so our database stays up to date. To meet the highest recognition standards and engine performance, samples of shelf images undergo a voting process for validation. Trax uses a cascade of state-of-the-art engines working in parallel to turn shelf images into actionable insights in a matter of minutes. Powering industry-leading retail solutions to drive efficiency, effectiveness, and revenues for the world's largest brands and retailers at global scale.
So this
SWB audio capture not
a
registered.
nice video in my opinion, and okay, here it passed directly to the flow. But talking a little bit, a few comments about the video is saying something that is, I think, interesting to give an overview on what is happening on Trax. So basically, is the main purpose is to collect several state-of-the-art models and the computer vision, and not only, and generate at the end a cascade flow able to generate insights of for the usable for the client. A nice point that is at the end, a point that it needs to be remarked, that is at the end of the presentation, is that our approach is not pure AI. Pure AI is very difficult to reach because in our scenario, we have a customer that want amazing accuracy, amazing recall, and this is not something that right now is so feasible with pure AI and the quality of image that we are having. So most of the time depends on the application on the product. Most of the time at the end, before sending insights to the client, there is a human validation part. So human is actively present in the flow, and we need to start we need to think a joint collaboration between AI and human in the loop, and then there are many ways that Trax is getting very big. We are kind of 1,000 employees, and everyone is doing a different project. We have a project related dynamic project that are all based on a smartphone application and immediate validation and immediate check, and other project that then involved post-processing and human validation.
SWB audio capture not registered.
I hope that I give an idea on, and the video gave an idea of what Trax is doing. And by the way, feel free to interrupt me if you have any question. And here I prepare an idea of a possible flow, just to make things clearer. Basically, we can imagine that we can go through a data acquisition process that, as we have seen, can be done by dome camera or smartphone or robot. And then we imagine that we have a shelf camera, a shelf image, and we go through product detection, price tag detection, both on whatever detection model we prefer. I took YOLO V5, that is what looks like performing the best currently. And then for the price tag, we can go through optical character recognition pattern. And for instance, we can think about Mustang Spotter V3, that is a work done by Facebook recently. And that allow us to recognize price, EAN, and whatever information is written inside the price tag. On the other side, in parallel, we can imagine about having a product classification algorithm that maybe we can focus a little bit more later, because the product classification algorithm that we want has to solve many different issues, and we are talking on fine grain product recognition as well as large scale product recognition. Then it depends on how we want to organize the flow. You can structure a lot of sub model for each retailer, each category, or cascade approach. But for instance, here we can say, for instance, that we put a ResNet or a
SWB audio
LTR
capture not registered.
Dataset, for instance, is allowing the long tail recognition. So from data and classes where we have a high number of sample till future learning and until also open world recognition. So being able to recognize novelty, that is another big problem that you can have in the retail world. A new product is coming, and you want to recognize it almost immediately, or recognize at least that is a novelty and is not one of the other products. Then all this information, as is seen in the video, has to be stitched together for two reasons. One can be a visual reason, that we want to provide to the customer the full shelf in a single picture where they can visualize all the information. But the most important reason is that we want basically to map single shelf images in a reality world. So a single shelf image most of the time has overlapping, and so having overlapping, we just base the analysis on a single image, we are going to generate a lot of duplicates alerts. And then I put a compliance node. The compliance is basically collecting all the information we are having and generating these alerts. This is more or less how we can think about a very simple flow to just have an idea on how the things can work. And here, just to keep the attention high, I put a picture, a stitched picture of a shelf image. And this shelf image is a pet food shelf store, and is containing some difficulties both for detection
SWB audio capture not registered.
For stitching, we can see that here we have many key points that are almost the same, because we have many duplicates product on different part of the shelf. And so the matching algorithm, in order to then provide a good stitching image, can be affected by this. As well as the density detection. If we want to detect product in so many instances of a product, we need to be careful. It's not easy to be able to separate and distinguish one product from another. So many products can be condensated into a single one, and so far so on. So one of the points that I wanted to stress in this presentation is that for us, models are not the real challenge. And I don't know if anyone here is working on image classification, but he has to be very competitive. It must be a competitive guy, because only this year in 2021, they exit like 50 papers about image classification or even more. And this means that on one side, the computer vision world is quite mature for the industry, but on the other side is still very competitive, and things are going out basically almost all the days, and it's difficult to keep track of everything. But at the same time, it's not making a lot of sense to start to investing that much time and research new models when the community is so dynamic, and they for sure invest a lot of time on that topics. So what is the real challenge for us is everything related to data, because we are managing billion of data every day.
SWB audio capture not registered.
Deep learning models, and that have to be trained with millions of shelf images that are uploaded on the cloud daily. So this is a real challenge. Put in place an infrastructure and a data management system that is able to handle all of this. And I feel also that in the community, they are stressing more and more the importance of data and the importance of having quality data. And this is not easy at all for personal experience to keep this data clean. We can imagine that on a at large scale, supposing that we have many stores where they are producing images that are different for orientation, they are different for resolution, and we want to keep all together, organize them, limited outliers and other kind of analysis. This is tremendously difficult, and is what I think is the big challenge right now in most of the enterprise. And if we have to rethink about a pipeline of data acquisition, data cleaning, and a general MLOps pipeline, we have the step of data acquisition. Then we have human annotation, and human annotation is difficult to be monitored. From an operation point of view, is needed to put in place a system that allow to annotate quality data. Just imagine about classification when we have a bottle of Coca-Cola, like in this image, that is half a liter, another bottle that is 1 liter, and it's very difficult to keep the
SWB audio capture not registered.
Even for human. And if human are not able to, then the model will not be able to, because the data will be massive. And for that reason, there are different techniques like voting system and training on taggers and so far, so on, as well as the data cleaning process. And after we of course, we need to retrain constantly this data, our models. So based on the data that are arriving, we need to retrain to keep always high the performance. And seems not that complicated, maybe said like that, but I can assure you that is a very difficult to have this kind of system. And so the limitation is coming when we are going to scale up, because when we are going to scale up, all this process is increasing exponentially the cost of maintenance with the number of new clients. Because if we suppose that we sign with a new client that is having 10 stores, we need to collect the data for all that 10 stores and start again to all the model training and so far, so on. And this is very expensive. For that reason, Trax is investing on looking for solutions that are limiting the training cost as much as possible, or also looking for solutions that are less expensive in terms of training. Right now, there is this new trend on the classification world of transformers and that are coming from NLP, that basically are showing very good performance, but as well as are showing that for reaching this good performance, you need
SWB audio capture not registered.
A lot of cost on training over that data. On the other side, fact is the cost of keeping a dynamic database clean. This is a very difficult task. You can try to apply and supervise processes to clean it frequently and keep everything up to date, but it is not that straightforward. Depends a lot on the data structure that you have, but on the data organization that you have, but is not straightforward at all. So just to give an idea about the difficulties on keeping the database clean, but these difficulties are also mapped on the keep having a recognition engine, a classification engine that is performing well. If you imagine here, we can see the question above is, are these product cans and like the can that is visualized in the image? And then if we go here, a little part of the product, it looks like all can, more or less. And this is a can actually, but this is not, it's a different kind of product. It's a alpha can, but for sure is a different SKU, so a different identifier. And this is even worse. At the end is end up to be a bottle, and this is a package of multiple cans. So if you imagine that taggers have to basically validate, recognize all these products, will be a process that is kind of totally, it has to be fast. So it doesn't have a lot of time to
SWB audio capture,
sure,
not registered.
Classified as a can, but the first product and the seller product are very similar, and there are a lot of probability that this will going to create a class containing two different two different class objects, basically. Few words about the inference infrastructure and saying how we are developing what we are doing. Basically, we develop everything on pure Python. We try to use static checker to have more control on the quality of the data. And the idea is that each model can, we are adopting a strategy where each model is a microservice. So to handle of this, we are developing the skeleton of our infrastructure in async IO base to in order to have asynchronous call on the microservices. Then all the microservices, most of them contains deep learning models, some of them not for sure. And this microservice has to be able to be deployed both on cloud or on smartphone or on robots. So we have to also cover the embedded system part. And to solve this problem, we adopt ONNX. ONNX is a very cool tool. I find some similarity, or maybe if there is some pure computer scientist here will kill me, with Java, because it's basically allowing the portability of the model in any engine, any infrastructure. And this is very
SWB audio capture, not registered.
Very different and variegate and more hardware. This also is quite easy to use and quite easy to export from, supporting a lot of almost all the common deep learning framework, TensorFlow, Keras, Caffe, PyTorch, everything is supported, and is not super stable yet. Is missing some feature, is not translating exactly every node perfectly. If you have some layer that is very specific, you can have some problem times that you have basically to create your own converter. But in general, if you are using classical model with not too much featured models, you have no problem to use ONNX for creating something that then you can use from everywhere, mobile phone and to I don't know, Jetson or everything. And the final idea is that we deliver endpoints if we reason about cloud-based solutions. So deliver endpoints means that we are basically, if you want to call a detection model after you put the credential, you just do a HTTPS request to the endpoint, and you will have the results of given an image, the results of the detection as well. This is the same fashion of the new library of Google for computer vision. It's very similar idea. And if we talk about the
SWB audio capture not registered.
Recently, with Trax, in collaboration with Alibaba and Facebook, support retail vision CVPR challenges, two challenges basically. Unfortunately, I think that the challenges expired the 20th, but unfortunately I arrived late with this presentation. Basically the two challenges are everyday challenge that we can have in our field, in the retail field, and that are basically trying to, given a shelf image like this, try to infer the price of each product. And on the second example is the one where we focus more, that is the large scale product recognition. But if we want to spend some word on product pricing, basically there are some part of the problem that can be solved easily. So we have the part of detecting the product, detecting the price tag, and run OCR over the price tag in order to read the price. What is difficult is the geometrical association between price tag and product. That like this doesn't seem super complicated, but the thing is that the rules followed by customer are not super strict. You don't actually know if the price tag is before, after, under, above the product.
SWB audio capture not registered.
The naive way with a geometrical association based on human-based rules, but would be interesting to find other possible solution for solving this problem, to maybe consider to annotate some data and try some kind of training, as well as try to exploit more the information inside the price tag, the other OCR information that you can get inside the price tag. On the other side, we have the large scale product recognition. This is very, very challenging problem in general in the retail world. As you can see in these couple of examples, we can have a configuration of product like the Aribo package, perspective on the product that are totally different of what we are having in the data set. And as we will see in the next slides, we are having a lot of common problem on the data that are reflective packaging, partially abstracted product, like poor photo angles, flipped product, completely rotated product, and one face of the product can be completely different from another face. And even more, and normal scenario, current deep learning classification model struggle to have satisfying performance when the number of classes are above 10K, but I'm being like generous because also with over 1-2K, they start struggling. And if we want to have a single classification,
SWB audio capture not registered,
or for a single store, we can imagine to have something like on a medium-sized store, 50K different product inside. And for sure, as we discussed also before, we can think about routing or routing and having a different sub model for each part of the store. But this is costly from a point of view of operation, as well as from a point of view of maintenance cost of each model. So it would be way better to have a model that is working for everything. But with normal classification engine, it's not super easy to reach that point. And for instance, for that reason, on Traxx, we are trying to exploit the a priori information that we can have on the configuration of the shelf to basically improve the classification. So here is again a way to stress the difficulties on the product classification. We have seen that before I was talking about the large scale product classification. Here I'm focusing more about the fine grained product classification. Fine grained product classification means that we want to recognize all these products as different ones, because they actually are different ones. Even if they look very similar between each other, they are basically different type of, you can see the image, we have different women with different hairs, blonde, curl, red, and different woman. And this is not
SWB audio capture, not registered.
For a classification model. Then even here, we see that, again, here the two products are different. One is head shoulder normal, the other one is head shoulder with two different type of strain substance into one. But it's not only that small difference, but it's also interesting to see that in one case we have a blurred image. And so it's getting even harder. Problem on different perspective, and as well, I think I'm almost sure that these are two different products, probably in a different size product. And this is the example here below. Basically, if you want to recognize this product in an image, and you want to recognize that the first Red Bull is smaller than the second Red Bull, is not easy. It's not easy because in an image, in a shelf image, you have you cannot actually understand the different sizing of the product. You have to use the context if you want to understand the different size of the product. But even in this case, it's not common. It's not that easy because the information that you have most of the time is partial. And another example can be this again, as two different, they looks almost as two same product, but they are not. And even the distinction is given by the small name on the bottom, and on one of the two products is obstructed by an obstacle or something.
Sorry, Federico, may I ask one thing?
Yeah, sure.
Very briefly. As you started talking about fine grain, I realized that I'm not sure I understand if this is a problem that you address at
SWB audio
at
capture,
second level
not
after
registered.
you did the large scale classification. So in other terms, am I supposed to distinguish different brands and also among different products, or do I already know that this is a Red Bull and I need to be more specific about the different kind or flavor?
This is a very interesting question. It depends. In general, you can adopt two different approach. What you propose is a cascade approach where you're first trying to because what I'm talking here is not a single model. It's more like an engine, and how you want to at the end reach the final results. What you are proposing is actually something that we used, and I don't know if other team used in Traxx, and is a cascade approach. So basically, first you try to recognize, let's suppose the first example here on the top, you try to recognize with a model all the categories. So you can recognize that if we imagine to have a large scale category model, we are able to recognize that this is a air product, and the one on the extreme right is Coke. And we have a first layer of classification, and then we move into a second model, a second classifier that is trained in detecting that this is the product for black air, and the other one is red air. And this is for sure a good option to move forward, and it's something that has been used. On the other side, it means that like this, you need to have
SWB audio capture not registered.
You can have also errors that are going to be propagated that can create issue. But the thing is that this is a good approach for classification, but and I think it's the current adopted right now, and then depends on the different part of the company. But is
my question is so sorry, I'm again
maybe I misunderstood you.
No. So you understood well, but I was it's not that I was suggesting that this is what I would do, but simply I was trying to see if this is the way you formulate the task, because it was unclear to me, let's say, what's the variability of the data your model is dealing with? Is it like all the products together, or is it a subset among which?
Depends. Depends on the approach you want to apply. The ideal scenario is that you have maximum variability on the data. You have a single model, and this single model is working for everything. This is what everything would like to have. Yeah, okay. But then, for sure, if you want to ensure maximum accuracy, this is difficult to reach. So the idea is that we can move for step, and the variability of the data at the beginning can be like separated. The classical I remember me a little bit the divide impera. No, you can divide the problem in sub-problems in order to solve the final issue. And this is something that is possible. So the thing is,
SWB audio capture not registered.
You can gain on accuracy, and you can gain on performance by separating the problem, by reducing the variability on the data on the specific submodels. But this means also that you have to take care of having multiple submodels and continue retraining on these submodels instead of having only one big models to handle all the time. And but this is something that definitely is a good option to reduce the variability in some data and to solve the big difficult problem, trying to separate that in a small problems. And but finally, what am I actually doing at Trax? And except by enjoying beer shelf, my team and I are developing a brand new solution on high quality image, which mix different data sources together to overcome all the previous mentioned problems to identify on-shelf products. This means that we are trying to see the problem from another angle. And basically the question that we made to ourselves is, what if I am in a shelf, and what I do usually to identify a product in a shelf, and how I can use this priori to improve the final performance of the model, and so trying to kind of simulate human behavior. And we realized that basically
SWB audio capture not registered.
We are a part of the solution, and we can combine them with the text on the product. And text on the product can actually solve many problems for sure there is some a priori that are high resolution image, but it can solve many problems in terms of sizing or package almost identical, but with a different flavor or a different I don't know, reduced fat package that are almost the same, but one has the indication that is a reduced fat package and other information like this. Another point that can be very useful is the context. We are having price tag. Price tag can give us context, as well as nearby product can give us context. If we see in the image here, the white one, we have 3 beer, and only one of the 3 is clearly visible on text and well pasted, but the other 2 probably the normal recognition engine may fail. Because we do not have the relevant feature, because are rotated, are half covered. So what if we use the good classification, the good recognition of the center product to try to recognize the nearby product? And here we are going to also think about clustering algorithm. So we are kind of a step away from end-to-end classification engine to get embeddings, maybe, and try them to use it
SWB audio capture
more,
not registered
way, exploiting the a priori information on the shelves. And that's all on my side. I think I stayed on the time, and thank you very much. If you have any question, I'm here to try to answer.
Thank you very much, Federico, for your talk. It was indeed very interesting. So, is anyone from the audience with a question from Federico?
Yeah, I have one. Hi, Federico. So what about labeling all this continuously acquired data? Do you have, how do you label them, and do you explore other solutions like supervised learning, for example?
Yeah, this is a very hot topic, and we can use other unsupervised approach to try to basically do a first round of labeling on the data. I know that on my team, we have some, my specific team in Paris, we have some people dedicated to the operational side, so all this part of labeling. The actual problem is that it can be convenient, but at the end, if we talk about tagging and let's say classification tagging, the cost of having a person that is going to check if all your data are correct or not.
SWB audio capture not registered.
A person that is labeling it by 0. So the point are two, or either we trust for some of the data, and so we limit the charge of data that are going to be validated by human, and in that case we have a reduction in cost. But if we want still to have all the data validated, it's not convenient. But in case you want to trust some data, some of them you feel like you have a confidence score for just for saying, and you say, okay, this I want to trust them. I keep inside my training and I start using it. In that case, it's convenient. I had just a discussion this morning and about this, and I know that Trax is going to invest more and more on optimizing labeling, but as well as is a very competitive world. There are many companies that are starting to doing similar approaches, so semi-supervised annotation, and they are getting very, very good results. So then it will come will be a question of we outsource that, or we keep it or we try to do an internal project on that.
Thank you.
You're welcome.
Hi, I'm Paula. I have another question, if I can.
Yeah, sure.
I'm sorry because I was setting up the YouTube streaming in the first minute, so maybe you said that and I've lost it. But because on the whole presentation, you focused mainly on quite a precise task that is
SWB audio capture not registered.
And that's super hard from what I've seen. But my question is, we were thinking about other similar stuff. For example, I've heard about Amazon supermarket somewhere, maybe in New York, using computer vision technique to automatically detect what are the objects that you pick. And aside from that, I was thinking, and I'm sorry if you already said that. What are the application of this? Because you focused on a super precise product that it seemed to be supermarket stuff, and I was wondering what are the application of this, and aside of that, maybe.
Yeah, for sure. Sorry, you were finishing the question. Sorry, I interrupted.
No. I'm done. Thank you very much.
Okay. Yes, for sure. Maybe I can say some word more. So basically, Trax is having the major marketing on what is called CPG. So CPG are all the brands. So it means that brands want to know if their product are in the shelf, are well placed. And so for that are investing a lot and are willing to pay. Then this is what Trax is right now the main business of Trax. What I'm working on is more Trax retail part, because coming from Quopius, where the main focus was on the retail, I still have like my business case. Most of the case is the retail watch part. Retail watch part means that the person and the retailer wants to have
SWB audio capture not registered.
The shelf. Something that I didn't discuss is that retailer have something that is called planogram, or at least I know that it's called like that, but maybe it's an internal name. Planogram means that it's like a virtual, an hypothetical scenario of the shelf. So basically, the manager of the store is deciding that with all the commercial agreement, Coca-Cola has to be on the third row of the shelf, and he has to always to contain 5 facing, and they know that this is leading to the following X income. And if at a certain point this Coca-Cola, instead of having 5 facing, is continue to have 2 facing of not facing at all, this is a problem for the retailer. And with Trax, you can basically create an automatic monitoring on everything is happening inside the store, and knowing always that the store has a full capacity. Another interesting use case can be the price. Having a price in a store that are not correct are not good for the retailers. This means that times to times, they can receive a control, quality check. And if they contains many, and it's happening a lot, it's happening like many price tags are wrong in a store. You are going there and you say, okay, here is written that is costly $250, but at the end it's costly, when you go in the checkout is $350. And there are quality check that can actually give you fees to the retailer if they do not have this. Fees are also
SWB audio capture not registered
of quality of the shop. Then there are other company related business that are like dynamic merchandisers. It means that you can exploit crowd to go and verify that, and it's a parallel project. So a normal person is going on the store and is taking photos for to send to Trax, and this is basically substituting the guy that is going all the day to the store to see if Coca-Cola is in the right place. This is another approach. If you don't have, let's say, an agreement with the store, but you still want in that store to know if Coca-Cola is there, usually Coca-Cola is sending a person to check that. With dynamic merchandising, basically you can use the crowd to check that, and then give to the crowd a pay back the crowd somehow with a bonus, a voucher, or whatever after some operation that has been accomplished. Sorry. And this is another things that is dynamic merchandising or shopkick. For sure, is also very interesting, the self-checkout that I think you were talking about, that I'm almost sure has been applied by Woolworths in US, and Amazon is trying it, where you go inside a store and you go out without going to the checkout, and everything is recorded, and you basically have an account over there, and it's starting the automatic payment of that. Not sure if there is any project intern on Trax about that. I have not enough visibility on that.
Yeah, okay. Now, thank you. You said a lot of stuff.
SWB audio capture not registered.
Yeah, ask something super quick. You were saying that there is, this issue of retraining, and I was wondering if it's really needed to do retraining all the time as you are changing clients, let's say. So if I move from a Carrefour, small size Carrefour or a large size Carrefour, do I have to retrain? Or if I change retailer, do you expect large changes, and what are the type of variations that require that the whole system is, if you need to do it?
Yes, this is again a good question. The retraining can be done for two reasons in this case. The main reason can be that the setting of the shooting is changing a lot. And at the end, we can almost talk about overfitting. You know, if you have your data are coming from a single store, and you are trying to basically go in a totally different store with a, I don't know, totally different enlightenment, illumination, different distance. You are taking shoot at different distance with a robot, and the problem like this, you can get into problems. But this is a limitation of how the model has been trained. If we imagine in a general, having a good model with enough variability, a good data augmentation, indeed this can be solved basically with a general at the beginning, and if
SWB audio capture not registered.
A major model that is working for retailer. but is sometimes is struggling. Then depends on the kind of model. If we are talking about detection or classification, maybe for classification, less for detection. Changing a lot the background, you are adding a lot of noise, and this can decrease the performance. Why is needed the continuous retraining is more for the continuous change of product in the shelf. New products are coming quite often, and if not a new product are coming, another problem is that packaging on the product when the product is changing. You are a brand that is want to change the product, the package structure. Maybe sometimes the change is disruptive, but it's change everything. But yes, the general idea is to have a single classification model per retailer, and I think it can be achieved. That. But then there comes all the other limitations we are having due to, as we discussed before, the approach, cascade approach, not cascade approach. The general idea is trying to simplify and keep the structure lighter, but on the same time we want to keep the same performance. This is not is a difficult trade-off.
Yeah, very interesting, in fact. Thanks.
You're welcome.
May I ask a couple of questions? So one is a remark and the other is a rapid question. I'm sorry, maybe it's too late.
Okay.
SWB audio capture not registered.
Okay, thank you. So my first remark was about the tagging of the price, so the associating the price to the product, and so my question / remark was if you can try to use some kind of optimal transport technique, especially if you have many price tags. Maybe is a good way to try and match using also other informations, but still it could be a tentative. And my other question was, if you want, is related to this last answer that you gave. So how your trained model is stable with respect to change of the product. Usually I think of maybe special Nutella or special Coca-Cola for events or something like that. Do you still recognize them directly, or you have to retrain? Like now there is Euro 2020, many beers, Nutella, Coca-Cola, they have special edition.
First, thank you for the remark. I will, for sure, I mark it down. I will look for it. Maybe we can then also open a discussion private to have more information about that. It can be a good point for me. And secondly, about the question you've made is a little bit tricky, because what we want is a fine grain classification model. So for being fine grain, it needs to be able to distinguish very slight change on the package.
SWB audio capture not registered.
But in general, if we imagine to have a classification model, in the perfect scenario, if this package is actually a new package because it's a new promotion, it should be a novelty. And it depends in a little bit how you tune that part of novelty detection. It can be either recognized as a novelty or either recognized as the closest product. It's because on all these discussion, there is also the word of novelty recognition that is again challenging and not easy. So if we suppose we have a new product coming for the Euro 2020, that is like a new beer product coming, and is totally different on shape and fashion, I would expect that has been recognized as a novelty. Then, even if it's actually the same product. In that case, it is going to be very challenging because you should add this to the class and start to mix class with very different packages. And yeah, this is a little bit the overview on that, I think.
Thank you very
I
much.
don't know if I answered your question exactly, because
Yes,
it's quite tricky, sorry.
Okay, let's thank our speaker, Federico. Thank you very much. Very interesting talk and very interesting discussion as well at the end of the talk. I think if we had more time, maybe we will discuss more, but unfortunately time's up. So let's thank our speaker again and see you all next time. Thank you, Federico.
Thank you very much
SWB audio capture,
for your
not
time.
registered.
Thank you. Bye-bye.
Bye-bye.
The recording has stopped.
Ok, Paolo, tutto a posto?